Welcome to AMT-Lab. For the introduction, first we are going to see and explain the About page. This project is called AMT-Lab because it is a product of organization, music and technology. This product is coded in Visual Studio Code VSC and most of the resources are hosted on GitHub, with one of them deployed on Netlify. In this project, we can learn music, math, and audio through high-quality visualization tools. As a student, I know how stressful and torturing it can be to study new knowledge. But don't worry, I transform those boring theories into fun and creative plays. The primary purpose of this project is to let everyone learn organization easily and in a relaxed way, with tools that are simple but useful. The three goals: discover, experimental, and practical, correspond to the three sections that I have developed. The most professional tools, which are the most complicated, hardest to develop, and involve complex coding and math logic, belongs to the third project, FF Visual. I will come back to explain this later. The core technology of everything is detailed animation, canvas, math database, web audio API, and safety prevention. Example, XSS vulnerability. Each tool provides comfortable and easy to understand design, precise calculation, high quality output, and security against malicious attacks. It is hard to develop because it needs to allow users to use it smoothly without any prior knowledge. So I must ensure the interface is clean and the theory is simple to understand. The user languages are HTML, CSS, JavaScript, JSON, and WASM. The most frequently used are CSS and JavaScript, responsible for beautification and functionality respectively. The main features of this project are Soundanalyzer, Sound plus Analyzer, Wave plus Math, FF Visual, FFmpeg plus Music plus Visualization Canvas, also the final boss. The challenges shown here are only the tip of iceberg, but these are the most severe issues. Unfull cycling, a sound wave generates imperfectly, without symmetry and equally. Second issue, cross-origin isolation (COI), a privacy policy made by Google to protect users from hackers or stolen information, but it also bans a powerful feature which is shared array buffer, which is the key for FFmpeg. Third issue, the FFmpeg rendering issue. The canvas does not run when FFmpeg is recording, so the result is incorrect. It's time to meet those powerful tools. As you can see, the output of FFmpeg is extremely high. 266 kbps for audio and over 2500 kbps for video. Unimaginable data for front-end rendering. The sidebar is the shortcut to all features, including the About page. For presenting the full web page, I will use only the big button right down there. As you can see, this is a switch interface of every single page. Let's see the first one, Soundanalyzer. For uniqueness, I designed every section with different colors and arrangement. Okay, straight to the point. As you can see, this section provides decibel, hertz, waveform, and acoustic metrics as result. I made two visualizations in it, waveform and spectrum. In the waveform area, the x-axis represents the timeline in milliseconds. In the spectrum area, the x-axis is arranged from left to right, low to high hertz. On the right-hand side, you can see the live analysis data such as volume level, dominant frequency, peak volume. Now let's try it. You can choose the analysis length 5, 10, 20, 60 seconds or live mode. Here I choose 10 seconds. I will speed up the video to save times. Hello, hello, test mic test. Test mic test. Here are the results of the analyzer. You can pause the video and read them carefully. This is the easiest section compared to the others. It provides sound type selection with math equation expression, Hertz slider with logarithmic scale that meets standards, decibel volume control. Let's try this. Let's see if it works. There will also be a status indicator showing whether the generator is active or inactive. You see. And also, if we slide the hertz or the decibel bars, it will change the canvas. But remember, never set the decibel too high, if or not it will hurt your ear. Now, let us meet the final boss, FF Visual. This massive project combines FF MPEG technology, music, and visualization. You need to ensure FF MPEG is ready and passes the COI. As you can see, you can upload your MP3 file here. Now I will put a sample file, test 2 seconds. Below the upload button, there are various options you can adjust. Bar quantity, bar height, bar opacity, bar radius, bar gap, and bar width. You can also adjust the gradient of the bars in color picker or hex value, and also the delay of the display in the second as a unit. And then you can also adjust the canvas style, choose from center, bottom, or top until top or bottom. And you can also choose the mirror bar for nicer style. You can also adjust the add-on only for the center form. You can adjust the pixel of the thickness or adjust the gradient of the line. You can also choose your own background or choose the provided background. Here I put the file called sample2.png. Next, we can add element to the video. First, we can add text. And then we can add some image. Here I put sample PNG. Here. You can choose whether edit it in double click it or edit it at the current element bar. You can copy or duplicate or delete it freely. When you are set up everything well done, you can choose the resolution of the export. You can choose Full HD, HD, 480 pixel, 360 pixel with 3 options of frame per second. When you are well done, you can export the video by clicking this button. Before you export it, you can rename it as example test underscore 1. If you feel it's too noisy, you can, just like me just now, mute the site with right click it and then wait for the capturing frames. When the video finish encoding, it will auto download. Don't worry about rendering time. It's normal if it's slow. For a 10-minute video, it may take up to 30 minutes depending on chosen resolution and specs. Okay, the file has been encoded successfully. So we will check the video quality now. As you can see, it has a crazy amount of the data rate for video, which is 5000 kbps, and then 60 frames per second and 266 kbps for audio. Let's see, is it really have this data quality? As you can see, it works normally and smoothly, and also having the really high resolution with HD. That's all for today, and these are all the functions and features I have developed. Even though the process was difficult, I achieved it, and this is a milestone in my coding journey.